For this problem, we are going to start with problem 711. And in this one, it is an example of the back titration. This back titration, it is for calcium carbonate, and an excess amount of hydrochloric acid is added, and then this is the subsequent products. What we're interested here is in the percent, and it says even the weight. The final goal for what we're interested in is the weight percent calcium carbonate in limestone. With this being the case, we have to, for weight percent, recall that to find weight percent, we need grams of calcium carbonate over our total grams, and it's times 100. We are given the total grams, and the total grams in the problem is given to be, in this case, it's 0.5413 grams, and that's our total. So now we have to go about finding the grams of calcium carbonate. So to do that, we have to know how much initially of this acid that we added to react with all of our calcium carbonates, and then what the next step is to know how much excess there was. So to sum up, you need to know the total acid added, subtract the excess, and this will tell you how much calcium carbonate. So this will give you the amount that reacted with the calcium carbonate. Okay, so let's get the total amount of the acid that's added, and that is given by the 10 milliliters, 10.000 milliliters, and the molarity of the hydrochloric acid. So let's get the total. So we have 10.00 milliliters. We are going to convert this to liters. So by doing so, we're going to convert to liters. And then we need our concentration. And the concentration that's given is 1.3296 moles of, in this case, hydrochloric acid over 1 liter. Liters cancel out, milliliters cancel out, and we're left with, this is the total acid that's added. These are in moles. So we want moles, and this value, and then to get the excess, subtract the excess, is the next part they give you, where it is the excess acid, and that was titrated with sodium hydroxide. And they give you the volume, and they also give you the concentration. So again, we can here, because sodium hydroxide reacting with hydrochloric acid is a 1-to-1 ratio, because of that, we can say that the number of moles that it took for sodium hydroxide to react completely with hydrochloric acid, the number of moles here is the amount that was in excess. So the numbers that were given are, in this case, it was 39.96 milliliters. Again, we're going to convert this to liters. Then we're going to multiply by the concentration. And this is sodium hydroxide and then the last relationship that we also know is that for every 1 mole of sodium hydroxide, we have 1 mole of hydrochloric acid. Okay, so now what we are going to be given here are the number of moles of acid that we added, number of moles that was left over, and then by doing the subtraction, we will be able to find how many moles were left over. So this value here gives us 0.1396 moles of hydrochloric acid minus 0.004012 moles hydrochloric acid. So therefore, this must be 0.0099 and 5 moles of HCl reacted with the calcium carbonate. Okay, so we have, at this point, we have 0.00995 moles of hydrochloric acid that reacted with the calcium carbonate. So then, now we just have a couple more steps. And in these last steps, we need to get from moles of hydrochloric acid to moles of calcium carbonate. Once we get 2 moles of calcium carbonate, then we just need to get 2 grams of calcium carbonate. And then we plug it into our initial equation here, divided by the total, which we already have, times 100, and there we go, we get our answer. Okay, so now let's get this to moles and then to grams. So we have moles. Moles of HCl. We know that for every 2 moles of hydrochloric acid, or H+, there is 1 mole of calcium carbonate. So we need to use this to now convert to calcium carbonate. So to do that, we know that there's 2 moles to 1 mole calcium carbonate. And then we can actually continue on with this step and use the molar mass of calcium carbonate, which is given here, and it's 100.087 to get to grams. So we are going to be given 1 mole of calcium carbonate, and then we will have 100.087 grams of calcium carbonate. This gives us, we do the math out, we have 0.497 subscript 8 grams of calcium carbonate. So last step, find the percent calcium carbonate, and that equals 0.497 subscript 8 grams calcium carbonate over 0.5413 grams, which is our total, times 100, and then this is equal to, we have 3 significant figures, so we should have 92.0% calcium carbonate. So that is your final answer for question 711.